Next topic, minterms and maxterms. Next topic is minterms and maxterms. Here first I am considering for two variables a and b. I am writing all the four combinations of zeros and ones. See, previously we have seen XOR truth table. Okay, for some combination of inputs we are getting output as 0, for other combinations we are getting output as 1, right? So that means here we can write the Boolean functions in two varieties. That means we can consider the combinations for which output is 1, or we can consider the input combinations for which output is 0. Okay, so here first we are writing minterm notation. That means minterms will produce output is 1, maxterms will produce output is 0. Minterms, here letter m, small m. So here I will represent m suffix I. And then maxterms, here capital M suffix I. Minterms will generate output as 1, maxterms will generate output as 0, like that. Okay, so here we are considering minterm notation is nothing but what? See, basically we are having two types of operators. That is, one is logical and other one is logical OR. Okay, right. So here I will consider logical AND. Okay, in such a way that for this combination of inputs, output has to be 1. Okay, so here for this case, I will consider if the variable is 0, I will consider it as complement of the variable. If the variable is 1, I will take it as the normal variable. Okay, here for minterms, I am considering logical AND, that means product. Okay, so if the variable value is 0, I will consider it as the complement of the variable. If the variable is 1, I will write it as the variable. Now, just observe here, I am having both a and b are zeros. So substitute a value 0, that means I will consider a bar. Okay. Here b value is 0, that means b bar. I am considering those two variables are literals. I am doing logical AND among those. Now you substitute here. A value 0, 0 bar is 1. Similarly b value is 0, 0 bar is 1. So 1 and 1 is 1. Okay. So by following this particular notation, okay, I will get the product terms here. Okay, those will produce. If you substitute the corresponding combination of inputs, here you will get output as 1. Next, similarly here, a value is 0, that means a bar, and b value is 1, b. Similarly here, a and b bar. Last one is a and b. See, here we are considering logical AND. Okay, by considering like this notation, if the variable is 0, I am representing as a complement of the variable. If the variable is 1, I am representing as the normal variable, right? So by considering these values and substitute here, you will get output is 1. Just check. Here 1 0, 1 and 0 bar. 0 bar is nothing but 1. So logical AND of 1 and 1 is 1, right? So here just I am writing the decimal equivalent. 0 0 is nothing but 0, 1, 2, 3. 0 0 2 1 1. We are having 4 combinations. I have written the decimal equivalent 0 to 3. Okay. Now the notation is m suffix I. That means here I will write m0, m1, m2, m3. m0, m1, m2, m3. Now here I have considered logical AND. Okay. Here I will consider logical OR. Okay. Here I followed like this notation. Here I will follow opposite notation. That means here if a is 0, I have considered as a complement, but here I will consider normal. Here if a is 1, I have considered as a normal, but here I will take it as a complement. Here I will consider logical OR. Okay. Here a value is 0, that means I will consider the normal variable a plus b value is 0, that means b. Now substitute here a value and b value. 0 plus 0 is 0, right? So I am getting for maxterms will generate output as 0, whereas minterms will generate output as 1. Okay. Here I am considering logical AND. Here I will consider logical OR. Here a is 0 and b is 1, that means plus b bar. Next, a bar plus b. Last case both are 1, that means a bar plus b bar. Substitute here, a value is 1, 1 bar is 0, plus b value is 1, 1 bar is 0, 0 plus 0 is 0. Okay, so here I am getting maxterms, so I will represent with capital M. whatever the decimal equivalent is there, I will put as a suffix. M0, M1, M2, M3. Just observe here, these min terms are nothing but what? Product terms. Similarly, max terms are nothing but sum terms, right? But in each product term, if you observe the number of literals, literal is nothing but either the variable or its complement, right? Here, how many literals you are having? Yeah, 2, correct. In each min term, you are having number of literals is 2. Okay, it is a 2 variable function. We are considering for 2 variable case. We are writing the min terms and max terms for 2 variable case. Okay, if whatever the product term I am having, I will call it as the min term, provided if the number of literals and the number of given variables, if both are matching, I will call that particular product term as min term. Similarly here, in each sum term, okay, you are having the number of literals is same as number of variables. Okay, if the number of literals and number of variables both are matching, then I will call the sum term as max term. You can write down. A product term is said to be a min term if the number of literals is equal to the number of given variables. Okay, next point regarding max terms, you can write down. A sum term is said to be a max term if the number of literals is equal to the number of given variables. So that means what? Min terms are nothing but product terms or logical and terms. Similarly, max terms are nothing but sum terms or logical terms. Here, number of literals is same as number of variables. Okay, fine. Now, why we are calling this is min, this is max? Simple. See here, if you observe, we are placing logical and. Okay, even if you don't put logical and, just by having a bar, b bar, you can understand that among those two literals, we are having logical and operation, right? Whereas for here, we have to put the logical or symbol, that is a mandatory, right? So with respect to bit, this is min, this is max. So accordingly, these terms came, min term and max term. Okay, so next point, what is the relation between small m0 and capital M0, M1, M1, M2, M2, M3, M3? What is the relation? Just observe. Here I am having a bar, b bar, here I am having a plus b. A bar b, a plus b bar. What is the relation? Complement, right? Complement. See, a bar, b bar, whole bar is nothing but a plus b. Or you can apply complement here. AB whole bar is nothing but a bar plus b bar. Okay, you can write down. Min terms and max terms are complement to each other. See, simple reason. Here we are considering the min terms for output as 1. Okay, we are considering max terms for getting output as 0. Right? Here if it is 1, obviously it will be 0 like that. Next one, min term properties. Min terms properties or properties of the min terms. Min term properties or properties of min terms. Yeah, I will discuss regarding the significance little later. Here we have considered 4 min terms, right? Add all those m0 plus m1 plus m2 plus m3. Substitute in terms of the variables. Okay. That is a bar b bar plus a bar b plus ab bar plus ab. In these two terms, we can take a bar as common. So b bar plus b is 1. Similarly, here you can take a as common. You will get b bar plus b. B bar plus b is 1. So here you will get a bar plus a, that is equal to 1. That means sum of all min terms is equal to 1. Sum of all min terms is equal to 1. Okay, you can write down first property of the min term. Sum of SUM. Sum of all min terms equal to 1. Mathematically, we can represent sigma is for summation I equal to 0 to 2 power n minus 1 min terms m suffix I is equal to 1. Sum of all min terms equal to 1. Sum of all min terms equal to 1. Mathematically, you can represent like this. Here for 2 variables, we are getting min terms 0 to 3. So I have written I equal to 0 to 2 power n minus 1 for generalized case. If you multiply any 2 min terms, what is the answer you are getting? Multiply any 2 different min terms. M0, M1, M1, M2, M2, M3, M3, M0. What is the answer you are getting? Yeah, 0. Right? Write down product of any two different minterms is equal to 0. That means I am writing like this: mi into mj is equal to 0 if I not equal to j. If I and j are not equal, then if you are multiplying the minterms, then answer is 0. If I and j both are same, that means, see here, suppose AB you are multiplying with AB, you will get AB only. That means the same minterm you will get, right? So if I equal to j, then it will be either mi or mj. If I and j are same, then if you are multiplying the minterm with the same minterm, then the answer will be the minterm itself. Okay, so these are the properties of minterms. Next, put the heading Maxterm properties. I am repeating the last property regarding minterms. See, if you are multiplying two different minterms, that is like m0 m1. See here, b bar into b is 0, b into b bar is 0, d into b bar is 0. So if you are multiplying two different minterms, output is 0. Okay, but if you are multiplying the minterm with the same minterm, suppose I am considering AB multiplying with the same, like m3 and m3 is nothing but AB and AB. So you will get AB only, right? So that means if both are same, I and j are same, then you will get either mi or mj. If if I not equal to j, then output is 0, like that. Go through your notes regarding minterm properties. We have given one statement. Okay, tell me the dual of that statement. Yeah, previously you are having sum of all minterms equal to 1. Sum is nothing but what? Plus. Okay, dual of that one is product, right? So there you are having output as 1, here you will get output as 0. Okay, product of all maxterms is equal to 0. Previously we got sum of all minterms equal to 1. Sum is replacing with product, minterms we are replacing with max. There we got 1 replaced with 0. Now product is nothing but pi. Previously sigma for summation, capital pi. Here the symbol pi is for product. Okay, I equal to 0 to 2 power n minus 1 maxterms, capital Mi equal to 0. Okay, here we are having 4 maxterms. Whether we are getting output as 0 or not, just verify. M0, M1, M2, M3. Find out this value. Substitute M0 is A plus B, M1 is A plus B bar, M2 is A bar plus B, and M3 is A bar plus B bar. Simplify this one, you have to get output as 0. See, multiply A with these two terms, B with these two terms. Okay, similarly here A bar with these two terms, B with these two terms. And then do further simplification. Just go through the second property of minterms and tell me the dual of the statement. Yeah, you can write down. See, previously we have mentioned product of any two different minterms is 0. Okay, so here you can write sum of any two different maxterms is equal to 1. That means mi plus mj equal to 1 if I not equal to j. If I not equal to j, then you will get 1. Let us see. Here I am adding m0 with m1. That means b plus b bar is 1, 1 plus anything is 1. Similarly here, b plus b bar is 1, 1 plus anything is 1. Similarly here also. Okay, if you are adding two different minterms, you will get output as 1. Sorry, if you are adding two different maxterms, you will get output as 1. If you are adding the maxterm with the same maxterm, like m0 with m0 only, like a plus b plus a plus b, you will get a plus b. That means same maxterm you are getting. So that means if I equal to j, then it will be either mi or mj. If both are different, output is 1. If both are same, then you will get the same maxterm. Okay, so for two variables we are having 4 minterms and 4 maxterms. Similarly for 3 variables you will be having 8 minterms and 8 maxterms. Okay, so for generalized case, you can just make a note. If there are n Boolean variables, then there will be 2 power n minterms and 2 power n maxterms. Just write the minterms and maxterms for 3 variables. Here I am considering 3 variables, total 8 combinations of zeros and ones. See, whatever the convention I have taken here for minterms, if the variable is 0, complement of it. If the variable is 1, normal. Logical AND. Okay, so here all the variables are 0. So that means A bar and B bar and C bar. This is, if you write the decimal equivalent 0 to 7 you will get, right? So here M0. Next, A bar, B bar and C. A, B are zeros, so I have taken complement. C value is 1, normal form. This one is M1. Like that you can write. Last one, all the variables are 1. So you will get A and B and C. That is M7. Okay, similarly here. For Maxterms, I followed this notation. If the variable is 0, I have taken it as the normal form. If the variable is 1, I have taken it as the complement form. Here I am using logical OR. Okay. So here all the variables are zeros. So that means A plus B plus C. It is capital M0. Next, 0, 0, 1. A plus B plus C bar. That is M1. And like this, for last one, all the variables are 1. That means A bar plus B bar plus C bar. That is M7. You can write down first Minterms, just complement it, you will get the Maxterms. Put the heading Algebraic expressions for Boolean functions. Here first we are having canonical forms, algebraic expressions for Boolean functions. Here we are having first category is canonical form. In this canonical SOP, canonical sum of products or sum of Minterms form. Another one is canonical product of sums or product of Maxterms. Suppose let us consider exclusive OR truth table. This is the exclusive OR truth table. Now if you observe the output Y, we are getting 1 for 2 combination of inputs. Output is 0 for other 2 combination of inputs. Right? So we can consider Minterms, okay, for which output is 1. Okay. So here we are having, see, whatever the output expression we are having, output Y, we can write that particular function we can represent in 2 varieties. One is sum of Minterms and another one is product of Maxterms. Okay. Here we'll consider the Minterms for which output is 1. So here I am getting 1 for 2 combinations. Right? What are the Minterm numbers? M1, M2. M1, M2. Right? Here we can write Y equal to M1 plus M2. Y equal to M1 plus M2. In terms of variables, how we can write? A is 0, B is 1. That means A bar B plus A is 1, B is 0. That means AB bar. A bar B plus AB bar. If you want, we can write M1 plus M2 as sigma M 1, 2. We can represent like this. Here, sum of Minterms. Sum we can represent with sigma. Small m indicates Minterms. Whatever the numbers we are having, we can put like this. So all these 3 represents sum of Minterms form or canonical SOP form. Here if you observe, we are having 2 product terms. See, A bar B is nothing but one product term. Similarly, AB bar is nothing but another product term. Okay, these product terms are summed together, right? So here if you observe, you are having 2 product terms. In each product term, the number of literals is 2, right? If the number of literals and the number of given variables, here number of given variables are 2, right? If the number of literals and number of variables both are matched, then I will call that particular product term as Minterm, right? In each product term, if the number of literals are equal to the number of given variables, I will call those product terms as Minterms. Here, those Minterms are summed together. That is nothing but sum of Minterms form. Okay, so we can write the output Y expression in another way. That also will represent the same function. Here I will consider Maxterms. See, other 2 combinations, we are getting output as 0, right? Whenever we are getting output as 0, that time I will consider Maxterms. This is capital M0, this is capital M3. Maxterm 0 and Maxterm 3. Now, what we are having? Product of Maxterms. Product of Maxterms. Y equal to M0 into M3. See, other than these 2 combinations, we are getting output as 0. So, here I am considering the Maxterms. Okay, Maxterms product together. Now, in terms of variables, how we can write? M0 is nothing but A plus B. M3 is nothing but A bar plus B bar. A bar plus B bar. Here both the values are 1. A bar plus B bar. Now just multiply A with these two terms. Similarly B with these two. Here A into A bar is 0. Right? A into B bar. That means I am getting this term. Now A bar into B is nothing but this term. B into B bar is 0. That means we can write the output Y in two varieties. One is we can consider the combinations for which output as 1, or we can consider the combinations for which output is 0, like that. If we are considering the minterms, then we have to sum those minterms. Okay. If we are considering maxterms, then we have to multiply or product. Here if you observe, I am having sum term. See, we are having logical or symbol, that means sum. This is one sum term, this is another sum term. These two terms are product together. These two terms are product together. That's why here we are calling product of sum. Here in each sum term, you are having number of literals is 2. That is same as number of given variables. If the number of literals and the number of given variables both are matching, then I will call the sum term as max term. Okay, here we are having product of max terms. This one you can represent, product is nothing but the symbol pi. Capital M 0, 3. Here sum we are representing with sigma symbol. Similarly here product representing with the pi. See, in the previous class we have considered two variables, and for two variables we are having 4 combinations of zeros and ones. Okay, I have considered the 4 minterms, 4 maxterms. Okay, there I got M0 as A bar B bar, like that. Okay, so there my intention is if my input for that particular input combination, if I am getting output as 1, then how I can write the minterm, like that I have considered. Here if you observe, I am having the truth table of exclusive OR gate. Okay, here see, for any particular circuit, okay, you will be having the input variables and you will apply those inputs, you will get the corresponding outputs. Okay, either in terms of zeros and ones, right? So we can represent the output in two varieties. One form is we can consider the input combinations for which output as 1, that is nothing but what? Minterms. Okay, so here I have considered sum of minterms. Okay, another variety is we can consider the combinations for which output as 0. If we are considering the output as 0, that time I will consider max terms. If I am considering output as 1, then I will consider the corresponding minterms, like that. Okay, so here whenever you are having, see, whenever you are supposed to design any circuit, any digital circuit, okay, from the given specifications, first we'll determine what is the number of inputs and what is the number of outputs. Okay, and then we'll write all the input combinations, that means in terms of zeros and ones at the input side, and we'll determine the corresponding outputs. Okay, there you will get in terms of zeros and ones, right? So whatever the expressions you are getting, okay, that outputs we can represent in two varieties. One variety is we will consider the input combinations for which output is 1, that is sum of minterms, or other combination is we can consider the input combinations for which output is 0. Okay, if we are getting output as 0, then I will consider max terms, product of max terms, like that. Okay, in this case whatever the expressions we are getting, okay, so here I have represented in terms of minterms, here I have represented in terms of max terms, like that. Okay, in general whenever you write the expressions for outputs, okay, whatever the expressions you are getting, that one will be either sum of minterms or product of max terms. After that, if simplification is possible, if you do the simplification, then we will get other forms. Okay, these are the canonical forms. Canonical form is in each product term. Suppose if you are considering sum of minterms, in each product term, number of literals will be equal to the number of given variables. Similarly, if you are considering product of max terms, in each sum term, you will be having number of literals same as number of given variables, like that. Whenever we write the Boolean expressions from the truth table, that time we will get canonical form, either sum of minterms or product of max terms. If simplification is possible, after that we will get like this. Suppose you are having sum of minterms, after doing simplification you will get sum of products. See, here we are having standard forms, standard SOP form, or simply we will call it as SOP form. SOP is nothing but sum of products. That means here product terms are there which are summed together. Suppose, for example, I am considering 5 variable Boolean function f of a, b, c, d, e. So I got the simplified function like this. Suppose a, b plus c bar d, e. See here, if you observe, it is a 5 variable function. Number of variables are 5. Okay. Here I got the function like this. Okay. Here I am having one product term. Here I am having another product term. These two product terms are summed together. Here if you observe, number of literals is 2. Here number of literals is 3. But the given number of variables is 5. Right? If at least in one of the product term, you are having number of literals is less than the total number of variables, then I will call that particular product term as simply product term. I won't call it as a min term. If in all the product terms, if you are having number of literals is equal to the number of given variables, then I will call it as min term, like that. So here I am having simply product terms which are summed together. This is called SOP form. Similarly here, standard POS form or simply POS, that is product of sums. For example, f of a, b, c, d, e equal to a bar plus b and c plus d bar plus c. For the time being, I am considering the function like this. Here if you observe, I am having two sum terms which are product together, right? So that's why it is POS form. Okay. Here if you observe, number of literals is 2, here number of literals is 3. But the given number of variables is 5. If in each sum term, if the number of literals is less than the total number of given variables, then I will call that particular term as sum term only. I won't call it as a max term. In max term, the number of literals here present is equal to the number of given variables, like that. See, in general, whenever you write the Boolean functions from the truth table, first we will get either sigma m, that means sum of min terms, or product of max terms. Okay. After doing simplification, suppose if you are considering sum of min terms, after doing simplification you will get simply SOP form. Okay. Similarly, if you are considering product of max terms, after doing simplification you will get POS form, like that. We will solve the questions, you will come to know the difference between the earlier form and these forms. Literal is nothing but either the variable or its complement. Suppose here I am having 5 variables a, b, c, d, e. Okay. Here I will call these 5 are the variables a, b, c, d, e. Literal means either the variable, that means a or a bar. Similarly b, b bar, c, c bar, like that. Whether the variable or its complement, I will call it as literal, like that. Here if you observe, a bar is one literal, b is another literal, like that. Here I am having two literals. Here c is one literal, d bar is one literal, e is another literal, like that. Yeah, in canonical forms, you will be having, if you are having considering sum of min terms, then in all the, whatever the min terms you are having, there the number of literals will be equal to the number of given variables. Similarly, if you are considering product of max terms, there in each sum term, the number of literals is equal to the number of given variables. Yeah, canonical form means it is a complete whole set, like that. After doing simplification, we will get either this form or like this form. If you are considering sum of min terms, after doing simplification, you will get SOP. Similarly, if you are considering product of max terms, after simplifying, you will get product of sum. You can make a note. A Boolean function can be expressed as sum of min terms form or product of max terms form. See, here we have considered y equal to sigma m 1, 2. That is same as pi capital M 0, 3. See, here we have considered two variables. Okay. We are having 4 combinations of zeros and ones, among which 2 combinations are producing 1. That means the corresponding min terms I have considered. If you know this particular equation, from that we can write the other form, pi capital M. Because see, for 2 variables we will get the decimal equivalent 0 to 3, right? Among those 4 combinations, out of which I am getting 2 are the min terms. Okay, 0 to 3, other than these 2 combinations, remaining will be the max terms, like that. Write down the question. The logic expression y equal to sigma m, he has given the min terms like this, is equivalent to 2. You have to represent this particular function in product of max terms. That means pi capital M. Here if you observe, he has not mentioned how many variable function it is. But by looking at the min terms, you consider the maximum min term value. Here its value is 15. 15 you can represent with 4 variables, right? So that means it is a 4 variable function. For representing 15, we require 4 variables. Okay. So that means if you are having 4 variables, you will be having 16 combinations of zeros and ones. That means 0 to 15, right? Among which these are the minterms. So other than these, remaining combinations will be the maxterms. You can write down those combinations. That means you will get 1, 2, 4, 5, 8, 9, 11, 13, 14. Next question. Given F1, F3 and F in canonical SOP form for the circuit shown below. Draw this circuit diagram. He has given the circuit diagram like this. Here he has given the circuit diagram like this and he has given the functions F1, F3 and F. Okay. He is asking what is F2 and he has given the 4 choices like this. Find out the output of each gate. You are having AND gate. Okay. Inputs are F1 and F2. So here you will get F1 and F2. Here you are having OR gate. So that means you have to add these two inputs. Here I am getting F1, F2. Another input is F3. That means F equal to F1, F2 plus F3. F1, F2 plus F3. Now, whatever the data he has given, let us substitute here. Okay. Here he has given F. F is sigma m 16815. Okay, I am writing like this. Sigma nothing but sum. Okay. M1 plus M6 plus M8 plus M15. He has given these 4 minterms. 16815. Next. Equal to F1. F1 he has given, these are the minterms. 4, 5, 6, 7, 8. Into F2. F2 we don't know, we have to find out F2 value. Okay. Plus F3. F3 he has given sigma m 1615. M1 plus M6 plus M15. Whatever the functions he has given, we have substituted that one and now let us find out what is F2. Since he has given 4 options, let us check one by one. Okay. First I am assuming option A. Okay, here I am having sigma m 4, 6. That means here I will consider M4 plus M6. M4 plus M6. Okay, now here we are having, actually what we have to do, this bracket and this bracket are product together, right? That means whatever the minterms here I am having, I have to consider one by one, I have to multiply with these two, right? So what are the minterm properties? Just go through once. Whenever we are multiplying two different minterms, what is the output? 0, right? Whenever we are multiplying the minterm with the same minterm, then we'll get the corresponding minterm, right? So here what we have to do, actually M4 we have to multiply with these two. Similarly M5 with these two, like that. We have to continue. So here when you are multiplying two different minterms, output is 0, right? When you are multiplying, whatever the minterm here you are having, if you are multiplying with the same minterm, then you will get the resultant same minterm, right? So here what I will get, M4, just identify the common minterms. In this bracket and in this bracket, whatever the common minterms are there, that will come as the output. Here M4, M6, both are present, right? So you will get output as M4 plus M6 plus M1 plus M6 plus M15, right? So here you are getting M4. But here if you observe, whether you are having M4, no, right? So that means option A is not correct. So since here we are getting M4 as the output, but here in the overall output F, I don't have that particular minterm. So just look at the options. Whatever the options contain 4, all those are wrong. So obviously option C will be the correct. Option C will be the correct. Let us see whether we are getting it is true or not. Let us see. Here I am having M6, M8. So here I am considering M6 plus M8. So here I am having two minterms M6, M8. Here also I am having those two minterms. So output I will get M6 plus M8, right? Plus here whatever the minterms are there, I am writing once again. M1, M6 plus M6 is M6. You can write one time. So you are getting 16815. That means option C is the correct. Yeah, I am repeating once again. See here output expression we have written. Here output of AND gate is F1, F2. Here output of OR gate is F1, F2 plus F3. Okay. Here he has given 3 functions. I have considered those data. Okay. F is what? Sigma m 16815. So I have written as sum of minterms. Okay. F1 he has given 4, 5, 6, 7, 8. Okay. And F2 he has not given. Okay, let us find out. And F3 he has given 1615. 1615. Okay, now I have considered option A. We are verifying whether it is true or not. I have considered F2 as sigma m 4, 6. That means m4 plus m6. Here what you have to do, this whatever bracket you are having, here you are having one more bracket, these two are product together. That means you have to multiply. Suppose if you consider m4, you have to multiply with these two. Then m5 with these two. Like that you have to continue the process. We know the properties of minterms. Whenever we are multiplying two different minterms, output is 0. Whenever we are multiplying the minterm with the same minterm, then the output is the minterm itself, right? So here in this bracket and in this bracket, whatever the common terms are there, that will come as the output. Here m4, m6 is there. Okay. So that means after multiplying this entire thing, you will get m4 plus m6 as the outcome from these two brackets I am talking. But here if you observe, m4 you don't have, m6 you are having, but m4 you don't have. That means whatever the options contain m4, all those are wrong. Now I am considering option C, whether it is true or not I am verifying. Here I am having m6 and m8. So m6 plus m8 I have considered, right? So here also m6 plus m8 is there. So when you are multiplying these two brackets, you will get the resultant value as m6 plus m8. Okay, so I have considered that one. After that, here I am having sum of other minterms. So I am considering one by one. M1 plus M6 will come. M6 plus M6 is M6 only. I am writing one by one. After that, M15. So here, whatever the minterms you are getting, here also you are having the same thing. Okay, since it is a multiple choice question, so we have done like this. Suppose if it is a numerical answer type question, if you are supposed to specify the minterm number, then what is the decimal equivalent? Decimal number correspond to that minterm. If it is a numerical answer type question, then if suppose whatever the minterm, that decimal equivalent if you ask, then what will be the answer? See here if you observe, this is the overall output. How many minterms I am having? 4 minterms. 1, 6, 8, 15. Okay. Here I am having 1, 6, 15. Right? So that means already I am having these 3. 1, 6, 15. Right? So if I can get only m8 from this overall multiplication, then that will be the answer. Right? So that means if I consider only m8, see here I am already having m1, m6, m15. Here in the overall output, you should get these 4 minterms. Among 4, I am already having 3 minterms, 1, 6, 15. So if I can get 8 from this overall multiplication, then that will be sufficient, right? So if I consider F2 as M8, that means answer is 8, like that. If it is a numerical answer type question, answer will be 8. Here, 1 minterm will be sufficient, M8. M8 multiply with M8, then you will get M8. Okay, you can make a note. If it is a numerical answer type question, then F2 will be M8. That means you have to enter only the decimal number, then answer will be 8, like that. See, for previous question, actually I am in the output function. If you observe, there are 4 minterms, among which 3 already available here. These two terms are product together. After that, sum with these 3 minterms, right? Already you are having these 3 minterms. You should get only one minterm, that is M8. So here if you consider F2 as M8, that will be sufficient. So if it is a numerical answer type question, if you are supposed to specify that minterm number in decimal, then answer will be 8. Okay, next question. There are 4 Boolean variables x1, x2, x3 and x4. The following functions are defined on sets of them. Write down these functions. F of x3, x2, x1 equal to sigma m 3, 4, 5. G is a function of x4, x3, x2 equal to sigma m 1, 6, 7. H equal to f and g. Then h of x4, x3, x2, x1 is. He has given the 4 choices like this. See here you are having 4 variables x1, x2, x3, x4. He has given function f like this, function g like this, and multiplication of these two is nothing but h. And he is asking what is the h function. He has given the 4 choices. Yeah, most of the people will give the answer as 0, but that is not true. See, previously whatever the example we have considered, okay, there whatever the functions we have defined, all those functions are defined as the same variables. When you are having the same variables, then when you are multiplying two different minterms, then output is 0. But here, if you observe, this particular function you are having three minterms, those minterms are defined on the variables x3, x2, x1. Whereas the function g having three minterms which are defined on the variables x4, x3, x2. Right? These two variables are not the same. Right? Like previously we are having two variables like AB, three variables ABC. When you are considering the same variables, then if you are multiplying two different minterms, then output is 0. But here, this particular function is defined on the variables x3, x2, x1, here x4, x3, x2, and if you observe the resultant h is the product of these two, their variables are x4, x3, x2, x1. That means here MSB is this one x3, here MSB is x4, here MSB is x4. Here we are having four variables. In this case, we won't get 0 as answer. Let us see. See, whatever the properties of minterms we have given, all those properties will be valid when you are considering the variables as same. Right? But here, variables are changing. For each function, we are changing the order of the variables also. Variables are also changing and the order of the variables. See here, we can write this one as, I am directly writing this particular function h equal to f and g. H is function of these four variables x4, x3, x2, x1 equal to f and g. Right? So here I am considering f is sigma m 3, 4, 5. Here 3 is nothing but what? 0, 1, 1. See, here I am considering two functions f and g. Okay. Now, sigma m 3, 4, 5, that is nothing but m3 plus m4 plus m5. m3 means what? 0, 1, 1. Right? That means x3 bar, x2, x1. 0, 1, 1. Next, m4 means 1, 0, 0. x3, x2 bar, x1 bar. Plus 5 means 1, 0, 1. x3, x2 bar, x1. Is it clear? This is regarding function f. Up to here is it clear? I have written function f. Okay, I am repeating once again. See here, you are having a function which is defined on the three variables x3, x2, x1. Here x3 is the MSB. Okay, here he has given sigma m 3, 4, 5. That means m3 plus m4 plus m5. Okay, see 3 is nothing but what? 0, 1, 1. Okay, in minterms, if the variable is 0, we will write as a complement. If you are having variable as 1, then we will write directly normal form like that. x3 bar, x2, x1. Okay, next 4. 4 is nothing but 1, 0, 0. Okay, x3, x2 bar, x1 bar. 5 is nothing but 1, 0, 1. x3, x2 bar, x1 like that. Okay, similarly you can write g function. Here sigma m167, that is m1 plus m6 plus m7. Now 1 is nothing but 0, 0, 1. That is x4 bar, x3 bar, x2. 0, 0, 1. Okay, next m6 is nothing but 1, 1, 0. x4, x3, x2 bar. m7 means 1, 1, 1. x4, x3, x2. Here you are having 1, 6, 7. Okay, 1 is nothing but 0, 0, 1. Next, 6 is nothing but 1, 1, 0. 7 is nothing but 1, 1, 1. Okay, we have considered f function, we have considered g function. Now we have to multiply these two. So here I am having 3 terms. Here also I am having 3 terms. First let us consider this term, multiply with these 3. Then we'll consider this term, multiply with these 3. Like that, we have to continue the process. See here, just by looking at, place the corresponding binary values 0, 1, 1. That is nothing but what? 3. M3. Next, 1, 0, 0. That is nothing but 4. Okay. Next, 1, 0, 1. 5. Like that. Yesterday we have, in the previous class, we have discussed with respect to the variables AB for 2 variable case. For 3 variable case, I have considered ABC. Right? Suppose there you are having M1, A bar, B bar, C. But here you are having the variables x3, x2, x1. Okay. Now let us consider this term, multiply with these 3. Here x3 bar is there, x3 bar is there. x2 is there, x2 is there. x4 bar, x1. That means when you are multiplying these two terms, you will get some term. See here x4 bar, x3 bar, x4 bar, x3 bar into x3 bar is x3 bar, x2 into x2 is x2, then x1. This one we have completed. Let us multiply this term with these two. Here I am having x3 bar, here x3. x3 bar into x3 is 0. Here x3 bar, here x3 is there. So 0. I will consider this term multiply with these three terms. Like that you continue the process. Here x3 into x3 bar is 0. Here I will get x3 into x3 is x3. x2 bar into x2 bar is x2 bar. So here I will get the term x4, x3, x2 bar, x1 bar. x4, x3 into x3 is x3. x2 bar into x2 bar is x2 bar into x1 bar. Multiply these two. Here I am having x2, here x2 bar. That means 0. Similarly continue with this term. Here I am having x3, here I am having x3 bar. That means 0. x3, x2 bar, here x3, x2 bar. That means you will get the term. When you are multiplying here, you will get the term. x4, x3, x2 bar, x1. Here I am having x2, here I am having x2 bar. That means 0. So that means here we are getting the three terms. Okay. See, whenever you multiply, you can write the order of the variables anything. But here the function he has defined x4, x3, x2, x1. After doing multiplication, you have to arrange the product term. Okay, in that what are the variables you are having? You have to arrange in the order 4, 3, 2, 1. If we didn't mention, by default we may consider x1 is the MSB. If you are having 4 variables x1, x2, x3, x4, you may consider x1 as the MSB. See, unless otherwise he specifies. Suppose in the previous class we have considered for 2 variables AB, for 3 variables ABC, similarly 4 variables ABCD. Unless otherwise he specify A is the MSB. Okay, but in this question he has mentioned, see whatever the variables order he has specified, by default whatever the starting variable is there, that is the MSB. See here I already written the functions, just observe. Here, see in the previous class, suppose for 3 variable case or even in the previous question if you observe, we have considered the variables, okay, what are the variables we have considered? On those variables we have formed the Minterms and Maxterms. Okay, what are the functions you are having, right? But here the variables are changing. Here this particular function is defined on x3, x2, x1, right? See, here Minterm notation may look like the same, but when you write in terms of the variables, then you are getting a function like this. Similarly, here g is defined on x4, x3, x2. When you write the sum of Minterms, you are getting a function like this. When these two functions are defined on different variables, or even the moment if your MSB is changing, right? Here MSB is x3, here MSB is x4. You may or may not get the equivalent value is 0. We cannot specify. Whatever the properties of Minterms we have defined, those properties will be valid when you are considering the two functions are defined on the same variables. Okay, so here we are getting like this. Here it is a function of 4 variables. x4, x3, x2, x1. That means here 0, 0, 1, 1. That means what? M3. 1, 1, 0, 0. That means 12. Next, 1, 1, 0, 1. That is 13. That means option A is the correct answer. Okay, for this question, answer is option A.